Hi there, this is Abhinav. Welcome back to Crescent Arts. I am super excited to share you all that we recently completed a milestone for this channel, which is recently we completed 1 month for this channel with a lot of positive vibes and also an exceptional statistics like 300 plus subscribers and also 8,000 views roughly. Thank you for this. But also, I am a bit disappointed that most of the viewers for this channel are not subscribing. Please do subscribe, which gives us a boost to do more interesting videos. In the previous video, we have seen what is Flutter, which is the second section of this chapter. In this video, we will deal with the Flutter architecture and also we will learn how Dart programs gets compiled into native machine codes. Before getting into the topic, if you haven't seen the previous video, please do watch it and come back to this video again. I will leave a link in the description below and also an info card. Now, let us walk into our topic. As we already discussed, this section contains two parts, which are understanding the Flutter architecture, and the second one is how Flutter and Dart codes gets compiled into native machine codes. Let us now get into our first part. Flutter architecture. We can divide Flutter architecture into three important categories, which is UI as code, platform differences, and the final one is CodeBase. Let us now modulate each of these and understand clearly. First one is UI as code. The most important part and also the thing which makes Flutter distinct from others is that it has that idea of building user interfaces as code, that is called as UI as code. Consider widgets, which we have seen in the previous section. We have seen that everything in the Flutter is a widget, including the page itself. This refers that we build UI in Flutter using a widget tree, which we will learn very soon. Next one is platform differences. So here comes the idea that you will have no visual drag and drop editors for adding buttons or text inputs or anything which users see or interact with to your screen or application. Instead, you will work only in code. We will write everything in code. Yes, I know. Although it sounds different at first, gradually we will understand that Flutter has a nice approach for that, which makes creating user interfaces with this UI as code a piece of cake. Finally, one code base. Besides this core idea of Flutter, this UI as code approach, it is also important to understand that Flutter applications do embrace platform differences while being based on one code base, which means although we work on one project, we still can create different user interfaces at some particular points of the application if we need it for the different platforms, because Android and iOS are not the same. Most of the time, it doesn't at all. But if it does, Flutter gives you the tools to find out on which platform you are running, so that if you are on Android, you can execute code A, else if iOS, you can execute code B. So Flutter gives you the full flexibility here. If you are already familiar with Unity editor, you can understand this far better since it is also a cross-platform game engine. As we have just seen, Flutter does not support any kind of drag and drop editors or no visual editor for Flutter. We just use UI as code for implementing Flutter. Let us now have an anatomy of this application built using Flutter. Firstly, the image asset, which we can find it over here. This is also a kind of widget. And then coming to this title, home services, this is a text kind of widget which we can find it here. And the second text is description. This is also a kind of text widget over here. And coming to the bottom bar or bottom sheet, we can again further classify this into three widgets. One is skip. This is a kind of button widget, and also the next button which is to the right hand is also a kind of widget, which is a button widget. And this page count viewer or page slider or carousel, whatever you call it, it is also a kind of widget in Flutter. Firstly, we need to implement this sheet and then we will navigate to bottom sheet. We can consider this above widget collection as body. So body widget contains image widget, title widget, and again description widget. That is, we can observe that body has three children. One is image, the second one is text, and the third one is description. Well, title as well as description are all both a kind of text widgets, whereas this image is a kind of image widget. And in here, bottom sheet, this also contains three widgets, which are skip button, carousel, and the third one is also a button. Now, this entire page, which is main.file, contains two children. One is body and the second one is bottom sheet. In turn, this body contains three children as we just saw. Also, in turn, the bottom sheet contains three children. This is how we can have anatomy of this application. Now, let us move to another example. Well, this is more simpler than the previous one. I can understand it. Well, the first one is app bar, which we can see it here in the coding. And then the entire section is called as body, which we can, well, yeah, which is this part of the code. Sorry. And now the one small button over here is called as floating action button. Well, this has some kind of platform differences, as floating action button is called differently for iOS user interface development, which we will discuss later in this video. As of now, as this is a kind of mobile, like Android application, we can call it as floating action button or FAB. Now, well, this is app bar, which is widget number 1. Then this is body, this is widget number 2. And coming to the button, floating action button, this is widget number 3. So in this example, the page, well, instead I will have a text over here. Yeah, well, page contains three children, which is app bar, the second one is body, and the third one is floating action button. Sorry, FAB. Well, this is the anatomy for this kind of application. Let us clear this and move forward. Well, as we just spoke about platform selection, this is how, this is the simplest example how we can have a platform selection in Flutter. With this code, we can observe that we are asking the machine that whether it is running on iOS or not. In case of iOS, it will have 70 dp of what we call it as height, and in other cases it will have 60 dp. This is the simplest example for platform selection. Well, we are now done with the first part of this section. Now coming to the section, coming to the part 2 of this section, how our dot code or Flutter code gets compiled into native machine code. Firstly, we have our dot code, which uses Flutter API or Flutter framework like widgets, utilities, user interface, building blocks, whatever it is. We use this Flutter API to build dot code. Now, this entire section, the compilation of this dot code into native machine code, takes the help of SDK. With the help of SDK, this entire dot code is compiled into native machine code. It is not like that it generates two different kind of codes for both the devices. It just compiles into native machine code for both these platforms. It does not create two different files. This is how it gets compiled into native machine code. As we earlier spoke that SDK acts as a kind of translator. It is not like that. In case if we provide a dot code for SDK, it does not come and tell that, like if the sorry SDK, it does not ask the dot code to replace its own original code into these kind of primitive types for each of the platform. Like this UI button in iOS, also known as widget.button in Android, but we write it as raised action button in Flutter. Raised action button. It does not replace the raised action button into widget.button or UI button as per the device. It just compiles. It does not replace or generate any kind of other codes based on your dot code. We must understand this clearly. It does not translate, or it does not replace, or it does not duplicate your file, or it does not change any of the line in your original dot code. Instead, Flutter has its own implementations. That's really important to understand and keep in mind that Flutter directly controls every pixel on the screen. Flutter does not compile our code to some native code or native alternatives. Instead, Flutter ships with its own engine, which controls the entire screen. Everything the user sees and renders every pixel on its own, and that gives Flutter a lot of control and a lot of flexibility. We do not need to take care too much of that because Flutter does it on its own. But it is important to be aware of that because that gives Flutter more control and fewer limitations, and therefore you implicitly indirectly get benefit from that. You have a good performance, you have a lot of power, and a lot of things you can configure. You have full control over how you want to build your user interface. With this, we can wrap our third section. Thank you. Thanks for watching. Please do subscribe for more interesting videos.